Alright, this is going to be number 4 to 6 of the problem bank. For this problem, you need to know, like I said before, that the area under the line of a force versus distance graph is going to be the work done. Another thing to keep in mind is that when the area is under the x-axis, the area is considered negative. So, for A, it's from 0 to 3, so it's going to be this block right here. And that's just going to be the rectangle, which is going to be 6, plus the area of the triangle, which is 1.5. And that's going to equal 7.5 joules. Next, we have it from 3 to 6. I see this triangle right here is equal to this triangle right here, so it's just going to be these 3 blocks right here, and since it is under the x-axis, it is negative, so it's going to be negative 3 joules. For C, I told you before that the net work is equal to the change in kinetic energy, which is 1/2 mv squared final minus 1/2 mv squared initial. And since it is at rest, then you know the initial velocity is 0. So your equation that you're going to be using is 1/2 mv squared. So let's try to isolate our velocity here. So we have velocity is equal to 2 work over mass square rooted. Now let's use that for C and D. C, velocity is equal to 2 times 7.5 over 4, which is going to give us about 1.94 meters per second. Next we have velocity is equal to 2 times 4.5. We know that it's 4.5 because we're just adding A and B, because it's in A we were doing 0 to 3, and in B we're doing 3 to 6, and they're asking for 0 to 6 here. So 7.5 minus 3 is 4.5 over the mass, which is 4, and that's all 2.25 square rooted, which is 1.5 meters per second. You're going to be seeing that a lot, so this would be a good equation to memorize if you are unable to derive it from the work equaling the change in kinetic energy. Next up, we have the problem with the bow. So when I look at this problem, I imagine 3 stages of the bow. In the first stage, the string is slack and is not pulled at all. In the second phase, the archer has pulled it back. And in the third phase, the arrow has left the bow. Let's pick a different color for the arrow. So pretend the arrow is right here. And then when he pulls it back, the arrow is right there. And then when he releases it again, the arrow is now moving. So what all of that means is that the archer during this stage is applying no kinetic energy. But when he pulls it back, he applies an amount of kinetic energy. And in the third part, by the law of the conservation of energy, since the bow no longer has the energy is transferred to the arrow. And that energy is going to be the net work, coincidentally. And so, you know that work is equal to force times distance, and you also know that the network is equal to the change in kinetic energy. So, you can show that force times distance is equal to 1/2 mv squared. And now, they want us to find the speed with which the arrow leaves the bow. So similar to the last problem, we isolate velocity. Velocity is equal to 2 force times distance over m square root. Now let's see if that works out. Velocity is equal to square root 2 times 200 newtons times 1.3 meters. Wow, that is a big bow. Over 0.3 kilograms. And that leaves us with 41.63 meters per second, which is exactly the answer that they give us. Next, in B, they say if the arrow is shot straight up, how high does it rise? So, recall that I said the energy is equal to, the total energy is equal to kinetic energy plus potential energy, and that potential energy, when dealing with gravity, is going to be mgh. Well, that same logic applies here. If he fires it straight up from this point right here, then at this point, the arrow is still going to have kinetic energy. But once it reaches the point where it begins to fall down, it will no longer have kinetic energy because there is no longer any velocity. So, that means that all of the energy is in the form of potential energy. Before, when it left the bow, all of the energy was in kinetic energy. So that must mean that kinetic energy, the magnitude of kinetic energy, is equal to the magnitude of potential energy. So, from that, we can say that mgh is equal to kinetic energy, which is 1/2 mv squared. Isolating height here, because that's what we're trying to find, h is equal to mv squared over mg is equal to v squared over g. Now let's see if that works. 41.6 squared over 9.8. Oh, and I seem to have forgotten the 2 here. Sorry. Over 2 mg because of this 1/2 here. And that will be 88.29. Which is similar to the answer they gave us. Okay. And the reason that they got 88.4 is because they did not round 41.6. So not realistically, but in the test, you may want to consider using the exact answer for velocity so that you reach the most accurate answer possible. But for our purposes, 88.29 is more than close enough. In this problem, you have a guy on a slide and he is traveling horizontally. And if you remember from your 2D motion unit, you know that when you're moving horizontally, in physics, when there is no air resistance or friction, that he is moving at a constant speed. So you can say that velocity is equal to distance over time. Oh, distance over time. Now, at this point, all of his energy is in potential energy. Since energy is equal to the potential energy plus kinetic energy, his energy at this point is all in kinetic energy. So therefore, the magnitude of potential energy at the beginning will equal to the magnitude of kinetic energy at the end of the slide. So, knowing that potential energy is mgh and kinetic energy is 1/2 mv squared, you can now isolate h to find that h is equal to v squared over 2g. And you know that velocity is distance over time, so distance squared over 2t squared g. However, this is only the distance from the top of the slide to the bottom of the slide, but you also need to find the distance from the bottom of the slide to the water, and that is pretty easy. Recall that distance is equal to initial velocity plus 1/2 at squared. Since there's no initial velocity in the y direction, then distance in the y direction is just 1/2 at squared, which is g. So your final working equation will be d squared over 2t squared g plus 1/2 gt squared. So let's plug in some numbers. 5 squared divided by 2 divided by 0.5 squared divided by 9.8 plus 0.5 times 9.8 times 0.5 squared gives you 6.327 meters. And that is it.